Okay, so here's a second example, and I might have to illuminate these a little better with my phone light. Maybe I'll zoom in on them. And so these are shapes that actually have square cross sections. Mm-hmm. And so I don't actually remember what these are, but it doesn't matter. But let's just say that this is square root of x going up like that. Yeah. In fact, I can tell by looking at it that it's not. We'll just say it is. So that we have a function y equals square root of x, let's say from 0 to 2.
That end is off camera. I think you zoomed in, but...
Yeah, thanks for catching that actually, because sometimes I forget to zoom out. So I have square root of x from 0 to 2, and this time when I slice, this isn't rotating around an axis or anything, this is just a shape. It looks like this, or or like this. Mm-hmm. And when I slice it now, I get squares. So how would I figure out the volume of this shape?
Well, so you would need to find the side length of the square, which, in this case, going out a generic point x out, the side length is going to be the y value, which is square root of x. So this one is going to be the integral from 0 to 2 of x, square root of x squared.
Okay.
And there's a pi here because we're not, it's x dx.
What does that dx represent? It's easy to forget it, but what does it represent?
So we're not actually chopping into squares because that would be two-dimensional,
okay.
And we wouldn't be able to add them up. We're chopping them into really thin boxes, kind of on this, like on that one. And then the smaller, and then dx.
I'll zoom. Yeah.
Dx is the width of one of the boxes.
Yeah, the dx represents the width of those boxes. Okay. So in this case, there's no pies. Why not? Because
we're not rotating. We're not like getting circles. We're getting squares.
Getting squares. Okay. And so this is easy. So the area of this, if this was square root of x, would be what?
It's this integral, which is it's x squared over 2, valued at 0 to 2, which is 2.
So the volume of this, if it was indeed y equals square root of x and produce these cross-sectional squares, would be volume would be 2. All right, let's go on to one last set of shapes, and we won't evaluate the integrals here. We'll just look at the shapes.